Good day, I'm Bagares.
And I'm Roberto Girao, and today we're here to teach you about.
Before we learn this topic, you must achieve to determine whether a function is a continuous or not through some rules and methods at a point, or in this case, a number, since we will not plot the function in a Cartesian plane.
So here we are here to discuss on continuity of a function on a number. So we don't have any of these fancy things. We just have this AWW board that I found online. I'm just here to discuss and how a function can be continuous at a number. So we defined by my past lectures by my classmates. Continuity of a function happens when a function is found in all other parts of the graph. It means there's no break, you don't see anything, and it's continuous. So in this part, we'll see how a graph will get continuous at a function. So it's pretty easy. You just have to remember these three things. First is a function is continuous at a function if first f of c exists. So f of c exists. I'm sorry for my really bad handwriting. It's really hard doing this with the mouse. So f of c exists. So this is pretty easy. So for example, you have a function f of x is equal to fx plus 1. That's a function. So f of c is simply just substituting the number that was mentioned, that was given. For example, x is equal to 5. So if we were to substitute 5 into the function, that becomes 5 times 5 plus 1 is equal to 26. So we can see here that 26 is a real number. So the first condition is fulfilled. So that's what happens when the first condition is fulfilled. Yeah, you first substitute 5 into the whole equation. So let's erase that. Sorry, I'm really new to these things, so pretty awkward, but we promise we'll help you get these things. Okay, then we go to the second condition. Let's change the color there. So we go to the second condition. Second condition, this is where you apply your knowledge of the past lessons in continuity, where the limit of the function exists. So if we have these pretty linear functions, remember how to find the limit is to just substitute it into the equation itself. So let's take the example earlier. The limit of f of x as x approaches 5. Earlier the given was 5. So we're just going to do the same thing. 5 times x plus 1. So we go back again with 26. So if we were to be frank, we could actually end and conclude that a function is continuous by just doing these two conditions, because we see that if we could go back earlier, f of c is equal to 5 times, oh no, not equal to, sorry for the mistake, and it's f of x, I'm sorry. So f of x is equal to 5x plus 1, so that's also 26. So I forgot to mention, there's a third condition. The third condition just says if the first condition, which is f of c, just substitute the constant, and the next condition, which is the limit of the function itself as x approaches the given number. If the third condition says if those two are equal, the limit, sorry for my handwriting, there, limit of f of x as x approaches c, if those two are equal, for example, this is 26 and this 26, so if that happens, there you have a continuous function. But if we would look closely, linear functions would always be continuous, because any number you substitute in there, except except things that are not in the scope, the function would always be correct. But how about things like, I'm sorry for that was the pen. Wait. There, eraser. So, what if we had the more complex function? What if we had this 5x plus 1, but it's over x minus 3? So now we have a rational function. Everyone knows what a rational function is as long as it has a ratio, which is division. So 5x plus 1 over x minus 3 can't always have the same things. So what if we can deal with the same thing, that with the same conditions, except the given is 3, as x is equal to 3. So we're gonna find out this function is continuous. So if we were to substitute the function, if we were to substitute the number into the function, let's say it is a function, because it would be wrong if this was not a function. Without even computing, you can see that the denominator would be 0. So 5x plus 1 over 0 is an error. I wouldn't even put it here. It's an error. So the first condition already says that f of c does not exist. But why don't we try looking for the limit? Now, if this was a limit that could be manipulated, it might be different. So, but this example, for example, the given 3, we can't manipulate 5x plus 1 over x minus 3. So sadly, condition number 2 is also wrong. It's also false. So that makes condition number 3 fail immediately. Even if you just look at condition number 1, which was this, that which was false of false, you can see that both of these are wrong. Let's change the color. Wrong. Both of these are wrong. So what am I saying here? It means you can only determine the continuity of a function simply if all of the 3 conditions are met. Okay. So now we've finished that, we can determine a function is continuity is continuous if 1, f of c exists, 2, the limit of f of x as x approaches c exists. And the third condition, where these two, the proper thing is to put both f of c is equal to the limit of f of x as x approaches c. So those are the 3 conditions to tell if a function is continuous at a specified number. So specified number can be 3, -3, 2. It can be anything as long as it's in the number 9 Cartesian coordinate plane. So that's all for today. You can see these 3. And for the review and everything, we'll have my partner here, Kyle Bagares, do everything that you'll need to recap. It's a pretty easy lesson, and I hope you can do well on our quiz. That's it. Goodbye.
Guidelines, and these guidelines are: number 1, f of c must exist, which means that if you substitute a constant to a variable of a function, then there must be an output that exists. Number 2, the limit of f of x as x approaches to c must exist, which means that if we substitute a closest value of a constant to a variable of a function, then there must be a limit existing. Number 3, these two must be equal to each other, which is the limit, and the output from the function must be equal to each other. This guidelines must be strictly followed. If one of them is not met, then the value is or the function is discontinuous to a point or to a number. So before we end this lesson, we will allow you to answer this equation that we provided and tell us if it is continuous at a given number or if it is discontinuous at a given number. The, the answer key will be provided in a description box.
So thank you for watching this video about continuity of a function in a number. We hope it helps you in studying calculus, and see you again soon in another installment of the next video.